My name is Ted Pennings, and I'm going to be talking about testing data visualizations today. I'm going to be talking about how we can use tools like Happo and Cypress to test that our data visualizations are accurate and correct, to test that they adhere to our product specifications, and of course to test that they actually load and that they work. So here's the agenda. We'll be talking about the tools, Cypress and Happo. I'll do a quick tour of data visualization just to make sure we're talking about the same thing, different chart types and so forth. Then I'll talk about how to test data visualizations, and then I'll talk about how to test interactions with data visualizations, the things that actual users would do. Okay, so let's start with the intro. Who am I? I'm a software engineer. I have a front-end focus. I write lots of React code. Been doing data visualization for like about around 4 years. I've been writing tests the whole time that I've been writing code. I feel very strongly about writing tests. I live in Portland, Oregon. I like plants and flowers and do some gardening. It's me over there with some peonies and roses. So this is not a marketing talk. I don't work for Cypress. I don't work for Happo. There are alternatives to Cypress and to Happo. This isn't a marketing talk at all. I'm talking about how you can use these tools to test your products and your software, but there are a lot of ways that you can do that with other tools and so forth, and a lot of it is like the general approach. All that said, I do believe that Cypress and Happo are excellent and the best at what they do. Okay, so Cypress and Happo. Cypress is a browser-based testing tool. It drives a real browser. It drives Chrome most of the time, the exact same version of Chrome as you use and your users use. It's JavaScript code. It's like very JavaScript. It feels like JavaScript. It's like very ergonomic in that way. So you write this JavaScript code and it does things to a browser, and you can assert things based on what's on screen and like grabbing values off the screen and so forth. It's open source and free. There is a paid add-on, the Cypress.io dashboard service. It has a lot of good reasons to use it. It enables test parallel, all right, that word, and that saves us about 12 minutes per test run at Lightstep, from 16 to 4 minutes. They also added some like analytic stuff for most commonly failing test cases and longest test cases and stuff. So this is a basic Cypress test. In this test, I'm going to a website there on that site.visit line. I'm logging in, and then I'm asserting that there is a chart that's visible, specifically that like get by test ID. It's a shortcut for getting an element, and it's a custom command, and that will find that specific element based on like its DOM attributes, and then I'm asserting that that element is actually visible in the browser window at the moment that this test runs. So there's a Cypress talk coming up next. Jordan Powell is giving a talk after this, automated testing, all the things with Cypress. Definitely go to his talk. I think it'll be really great, and I'm looking forward to hearing about the way he uses Cypress. I'm going to be focusing on data visualization and interaction testing. I'm not really going to be talking about Cypress broadly. There are a lot of things I'm skipping over, like authentication, how you use Cypress against different environments, dealing with feature flags, how you set it up in CI. There are also some like best practice things like that command I showed before, and like the use of commands in general. I'm not going to talk about that a ton, but I'm happy to discuss any of that in the chat after this talk and after the next Cypress talk. I'm looking forward to getting to talk with all of you about how you use Cypress and questions and all that. So Happo. Happo is a screenshot testing tool. With Happo, the test is a visual diff. If you like imagine a code diff, the test is like a visual diff in the same way. So this is an example here. You can see this test over here, the cursor moving. I changed the chart from gray to magenta, and Happo caught that. Maybe I didn't mean to change it to magenta, probably didn't mean to change it to magenta. So it's nice that Happo caught this change, and you can see the before and after with that nice swipe. You can also review it. Yeah, so this is a paid service. It's not free. It's like a regular product. I found that it's like a very like reasonable price. Like the cost of it didn't even come up when we were considering it at Lightstep. All right, so I want to do just a quick tour of data visualizations, like 2 minutes, just to make sure we're talking about the same thing. So, when we talk about that, there are some basic chart types: line chart, area chart, bar chart, spark lines. So let's just look at those super quick. So here's basic line chart, nothing fancy. This is an area chart. It's basically the same thing with like a gradient below it. But when people talk about an area chart, they usually mean this kind of chart where the areas are stacked on top of each other. And you can see here this like orangish color AMT. Its value is 2500 at this point, but it's well above that level. It's because it's like stacking on top of others. Then there are also bar charts, just sort of normal bar charts. I think I mentioned spark lines. These are spark lines. They're basically tiny line charts, usually with fewer points. And then there's some kind of fancy chart types, like a histogram. It's essentially a bar chart, but it shows the distribution of things. So in this example here, for that highlighted bucket, that highlighted bar, it shows 21.8 milliseconds to 23.6 milliseconds, and it shows the number of spans, the number of like events that took that amount of time. So this is showing the distribution of how long things took. And then there are also some chart types that are more like graphs, like network diagrams and org charts and that kind of thing. Those come up with a lot of forms of data visualization here too. So this is showing the relationship between like operations, between functions and service calls for this particular thing with errors. So this is another type of visualization. All right. So we went over all these. X-axis, y-axis, that's pretty much always there. X-axis is very often time for like a time series chart. Cursors and tooltips are really important. We're going to talk about that later. From my experience, they're usually the hardest part of making a chart. Both like formatting the data and all that, but also like the interactions that a user has with them. I mentioned there are some other forms of charts, like the entity graphs, that like diagram I showed with the red circles, network diagrams, sports brackets fall into this category too. They're very much a chart and a data visualization, like all of the other things we're talking about. So let's talk about data visualization interactions. The most common, of course, is like hover. That would involve like a tooltip and a cursor that like shows you the values of a chart and so forth. It might also do some things with adjacent content, like highlighting like rows of things or showing data in a table for those values. I'll be specific about what I mean there. So I'm talking about this here. So I'm like hovering over these things in this sidebar, and it's changing the specific items that are highlighted above. There are also click interactions. That's just maybe toggling lines on a chart, opening a pop-up. There might be like starting a selection. Click and drag, I think, is like very, very common and kind of hard to test, but I'm going to show how to test it. So zooming would be an example of that, panning to like move around on a chart and all that. Filtering, rearranging things. Those are all actions that you would do with like a click and drag. It can be kind of a lot. Keyboards doesn't really come up a lot with data visualization. I can imagine in like a very large chart, like using the arrow keys to like move around left and right, but that's, I don't know, I can't imagine a lot more. Mouse out and blur, those are really important. When you leave the chart, you want to make all of the chart chunk go away, all the tooltips and all that stuff. Like you don't want that hanging around. Okay, so let's talk about how to test data visualizations. So where do we start? First of all, what do you want to test and what do you need to test? Often there's a big difference between those two, and a lot of it also has to do with like what your responsibilities are and what the responsibilities of your colleagues and other teams are. So questions to ask: do I need to test the accuracy of the data? If I'm just building front-end visualizations that display something that comes from an API, do I need to worry about whether the data is accurate? Or is that something that the people who are storing the data and giving it to me, is that something that they will take care of? Do I actually own the data is another way to put that. Is mock data sufficient? Maybe it is, very often it is, but sometimes it's hard to get like meaningful things out of mock data. Things that you might not expect can be avoided in mock data because it's like very controlled. Then do I need to test the usability or availability, the end-to-end flow? So that's like elevating the test beyond like the level of like, do these lines look correct? Are these like the correct colors? Is like the data being plotted correctly? Now we're talking about like, do my charts work after I deploy my code every time? Like, can I check that they're working at like any point in time to validate that everything's good? Another question to ask: how often will these tests run? And who will know when they break and who will fix them? These are questions that come up with all kinds of tests, and these data visualization tests and end-to-end type tests are exactly like that. So not to leave a bunch of questions without some answers, this is what we do at Lightstep. We run all of our tests on all of our front-end code changes. Every commit, every PR, all the tests run on that. We run all the tests after every deployment too. We have automated deployments to our like staging environments, and then manual ones up above that. And after those tests, we after those deployments, we run all the tests. It just takes a couple minutes, and it gives us a lot of confidence. And it's also very fast. It's faster than us like doing the manual QA. It just goes out and validates everything. We use a mixture of real fake data and fixtures. By real fake data, I mean that we have like a very predictable like random data generator. It produces data that looks a lot like what our customer data would look like. It's very predictable in that it produces like the same kind of shape of data, but there's like some variability in it. It's what our salespeople actually use, and our tests, our Cypress tests, use that too. So when we test our software using Cypress, we're also testing the demo flows that the salespeople use, and that's been really great for just ensuring that we have a lot of confidence. There is a sandbox where you can sign up. You can see how our product Lightstep works, but you can also see what our fake data looks like, and you can even go like inspect and look at our data test IDs and all those things if you want. So let's write some tests. Let's test a line chart. Very basic chart. These are the things that I think are important to test. That it's visible, that it's on the screen, that it's loaded without an error, without a timeout, and that it's rendering data. We'll get to what that means. But yeah, so visible, that it loads without an error, that it renders something. We're done. This is one of our actual tests for that kind of thing. So we're going to a page in the application here, and I have a little before each block, logging in and all that. And then we are testing that the charts load with data, specifically these 3 charts. So we're getting the chart element, and then we have a custom function to assert that the chart has data. I'll show that function in a second. But this tests that when we log in, when we go to the place, there's a chart, it's visible, it's loaded, it has data. So what does that function actually do? Seems like a lot of magic, it's a little bit too short. So what does it mean for a chart to have data? And how specific do we want to be about that? The test that I'll show you, it has like a complicated squiggles sort of view of what data should look like. And if you look at this, it's basically squiggles. They're, like pretty like uniform. There's a pattern, but there's some squiggles going on. So it's complicated squiggles are good enough assertion. Let's talk about that. For this particular command that we wrote for this assert chart has line data, yes, complicated squiggles is actually what we're looking for here, because there are a lot of different things that we're trying to test, and that the chart loads and then it has something that looks like data is what we want to test, that it has data-like contours. And that's just one kind of test, one like aspect of the testing strategy. But I think it's an important one, and that's something that we run on every single commit and every single deploy, because we want to be sure that charts load and there's something data-like. So this is what complicated squiggles looks like. It's a Cypress command, a custom command. So this is the syntax for adding a custom command. That assert chart has line data command name. It operates on an element that it's been given. So what that means is that assert chart has line data operates on the element here, the latency chart element. And given that, there's a get. We use recharts at Lightstep. It's a really good charting library. I recommend it. So there's a get to specifically find the SVG path within that container element that we were given. There can be more than one, so we grab the first one, and then SVG paths align have a D attribute, and the D attribute is this like crazy string with like a lot of capital M's and like just a bunch of stuff. It's like point here, move to here, point here, move to here. It's there's a lot to it. So we're testing that there's a lot to it. We're testing that it's a complicated squiggle. Specifically, the attribute D is a string, and we're testing that that string should have a length of at least 2 kilobytes of data. So complicated squiggles is cool, and it definitely has its place. It's a really fast and easy assertion, so I think you should use it a lot, but we've got to do better. If my product only loaded with complicated squiggles, you wouldn't want to buy that. You want something better than complicated squiggles. So what do we need to test? We want to test the data loads every time. We've got that with complicated squiggles, check. We want to test that the data is actually accurate. I think this is the most important test. This is like the reason why we're here right now for this talk. And we want to test that the data is formatted based on our product and design specifications. We don't want like Magenta sneaking up on us like it did earlier. So we test all of these things differently. Happo is actually going to help us a ton with testing these two things. Happo is going to be the answer to testing these two things, at least in the way that I approach this problem. So to get to that of what Happo is, first I want to just mention that like Happo is most often used with Storybook. Storybook, React Storybook is a way to get like an encyclopedia, a compendium of all of your like UI components and elements and widgets and like all your React things. You can create a story like what's going on here for any of them. Maybe not all of them because there's like a little bit of expense, but definitely for a lot of them, you can create a story like this. And you can put different props in those elements to represent those different UI states. So here, I'm creating a story for the success state of this chart. I would also recommend testing error and empty states. Loading can be tricky because of like animations and stuff. We're talking about like visual diffs of screenshots. So if there's an animation, there's always going to be a diff, and that test is not going to pass. So now that we have Storybook, we can get PR diffs. You can see here that there is a Happo GitHub status check, one diff, a bunch of other things that aren't changed. And here is the same thing I showed earlier with that chart that became magenta. We didn't want that. We didn't expect that. So that was a PR check. Happo found this change in the code from that PR, caused this failing Happo check, and alerted us to the issue. We could also go review it, and you can click accept here if you do want your charts to be magenta. There is some plumbing required to make this happen. There's a lot of really great documentation on how to do this. I think the major plumbing is actually in Storybook. The Happo side of this is pretty straightforward. And I have to give a shout out to all my colleagues at Lightstep who've done the work to plumb this up. It works really great for us, and I know that they spent some time working on that. So with this test, we can have confidence now that our data, our charts, are formatted based on the product and design specifications. We can see what happens when we deviate from those specifications. Specifically, our PRs have a failing check that cause us to go investigate it. And if it is a warranted change, we can accept that and have a green PR check. But now we have a test that our data is formatted properly. Next goal. Data is accurate. We need to ensure that the data we display is an accurate representation of the data that comes from our backend source, whatever that is. Specifically, like given that data, we want to make sure that we chart it properly, that the lines look right and all that. That's, I think, the most important thing to test. You don't actually have to test all of it, though. First of all, I don't think you have to test it on every single commit or deployment. You can have like fixtures that repeat the same data. In this test here, we have just fixture data. And given that input fixture data, we can test that it's transformed properly. One thing here that's out of scope, we don't really want to repeat the testing that another team is going to do. If there's another team that owns the data, if they own the backends and all that, we don't need to test their work. We can trust that they're testing everything adequately And if that's not the case, that's a different problem and a different talk. So let's not focus on testing things that are outside of our control too much. So as you can see, Happo is more than a styling test. Here I did some stuff to the math and specifically to the transform from like the backend data format to the thing that's actually charted. And you can see that the bars kind of changed. They still have the same shape, so we might have like easily missed that. But you can see, like for example, on this y-axis here, that the 1000 turned into a 1200. So everything kind of shifted up a bit. Our data is not accurate anymore. So to make this happen, we're using stub data, just JSON files with like the big blobs of data you get from like an API response. Ideally, these would be like very realistic. So if your charts have like a bunch of lines, like a very multi-series chart, you should definitely have a Storybook entry and a Happo test with a bunch of lines. And if you have like kind of weird things with like one giant line and a bunch of little lines, that's kind of important too, because you might like easily lose that like resolution on the little lines, especially if you made some changes to like your like stroke weight or something like that. So think about all the variants that your charts would have based on the shape of the data, and also what a user would like ask about, what a user would wonder. Make sure that you have that covered too, because you want to cover this as like a form of unit test, but also as a form of user story testing. So with this, I think we can have confidence to say that the data is accurate. With this example back here, with the chart changing, we can see actually that even though the data looks basically the same, it's changed, and our charts are no longer accurate. There's something wrong here. There's something that we want to investigate. And in this specific example, we would get a PR check that fails. We would be able to go look into it and see that our screenshot test has failed. We could see exactly what we're looking at here. So you might want more control over this. There are some limitations of Storybook, like specifically it is it's not like really a browser. There aren't any like interactive components. You can't like click or like do any of the things that a real person would do. So you can use Happo from Cypress. There are other plugins actually too. There's like a long list. There's a Cypress webpage for visual testing. There are like 5 different plugins and vendors for this, but sticking with Happo, I really like Happo. You can use Happo inside of Cypress. There's a really great package from Happo that makes that possible, and this is critical whenever you want to manipulate state as part of your screenshot testing. What I mean by that is, like, if you want to hover over a chart and see a tooltip, and that hover is a mouse event, that's not something you can easily do in Storybook, at least not as far as I know. So you would do that in Cypress. You would hover over the chart and have a screenshot, and I'll show that. You want to make sure when you're doing that you use fixtures for everything and that everything is completely repeatable. Thinking of that like loading spinner animation example I was mentioning earlier, if you have like the slightest change in your data, Happo is going to pick that up, and you want that. So you need to make sure that your data is exactly the same when you're doing this. Use fixtures for everything. If they're animations, you definitely want to wait for those. A lot of charts when they render will like the lines will like go up and like do some things. You want to wait for those animations to end. And here's how you take a Happo screenshot. It's just a Happo screenshot command. It's like very, very ergonomic. you just invoke that on an element and it takes a screenshot. And you can pass in a variant which like gets added onto the name of like the Happo test case essentially. So I want to give a shout out to my colleague Dan Diaz at Lightstep. He set all this up for us, and it's been like incredible. It's changed the way that we do our testing. So many thanks to Dan. Quick recap. So we've got a few things we want to test. We want to test that the data loads. Cypress is perfect for that. We can test the data loads in our like local controlled environment. We can run that test against like a production environment. We could even run that test against customer data, and we could run it as often as we want. We could use the real backends, or we could use fixtures. In the case of fixtures, or like testing that like the plumbing from like the fetch request up to like the chart pixels. We're testing that. So that's data loads. Testing that data is formatted properly. That's, I think, actually a really straightforward test when you use Happo and Storybook. I should have mentioned there are other like screenshot things for Storybook too, like Percy and stuff. But I really like Happo, and they make this like dead simple. You get the PR checks that are really nice. I think it's the best approach to that. Next test, data is accurate. So this is where we have to specify what we mean by that. If we're looking at like stub data fixtures and all of that, Storybook is like great for this. It's fast. If we want to test like something like more like nuanced, that is something we might test with Cypress if we have like interactions we need to do on the data before we assert it. You could also do basically the same test as the Storybook test, where you just have the element in your app on like a page or whatever, and you use fixtures to control the data going to that. Those approaches will test that your data is accurate. All right. So we've talked about testing data visualizations. We've talked about how to test that your data loads, that it's accurate, that it's formatted properly. Let's talk about how you test the user interactions with that data, because that's extremely important, and that leads to like the stickiness of your product, that people wanting to like come back and use your product over and over again and find something useful in it. So I'm going to show how to test a couple real user interactions, specifically hovering on a chart. When you do that, you usually expect a tooltip, and we want to make sure that that happens. We also want to test when you like click and drag on a chart, because that's like a super common chart interaction and like very important and useful. The thing that happens when you click or drag, that's like up to your product. That's not like specific to the test. And I guess you could say the same thing about hovering too. So without the tools that we've been talking about, without like Cypress, without Happo, it's basically untestable, these two things. Hovering on a chart shows a tooltip. Like, how are you going to test that? I mean, I guess you could test it like with Selenium, with like a bunch of like selector things and all that, but that's really the only way that comes to mind for me. I think it would usually be a manual test, and clicking and dragging and having that do something interesting and being able to assert the visual state during and after that interaction is definitely not something that would have been available to us before these tools. These are also interactions that people care a lot about. These are like at the heart of your product. They lead to that like stickiness I was talking about. They're also really important when you're showing someone the product for the first time, because it helps people get excited about what they can do. So you want to make sure that those things work. Hover. Hover's a little tricky. Cypress can simulate JavaScript mouse events. There's a sci.trigger function command, and the sci.trigger command, you give it an event. You give it like all these mouse events that I've listed. You can give it like other, like basically anything you would have like a document add event listener for. Any of that, you can have a sci.trigger. You can also trigger click, but sci.click is like meant for that, and there's a lot of other like good stuff going on with sci.click. So don't click with trigger. And these mouse events can kind of get nuts, as you can see here. So when you're doing this, it's really important to check your targets. I'll show what that means in the next slide. But when you fire a mouse event, if you fire it at the wrong target, it's not going to do anything. And you're going to wonder if your code doesn't work, and you might forget that your test doesn't work. that happens to me a lot. So check your targets, make sure you're triggering things on the right element. Also, the JavaScript mouse events are pretty like easy. Sci.trigger makes this like really easy. But the CSS mouse events are pretty hard in Cypress. There isn't like an out-of-the-box support for triggering like a CSS pseudo-class like hover. There are some options involving some of the like kind of lower level testing APIs that Chrome exposes. But I think it would actually be a lot easier if you're going down this path to just use like invoke show or invoke CSS. There's also commands. The value here is the jQuery function name, and then it takes the arguments that the jQuery function name would take. That's how the invoke works from Cypress. Use that if you can, or like see if you can avoid hover, because that's kind of tricky. Hover test. So we're here. All right, we've got these lines. We've seen them before. We've talked about them a lot. Here's the tooltip over here. And we have these numbers in the tooltip. We actually care a lot about those. That's an important aspect of this. And we want to assert that it appears, first of all, that it appears in the right place. We could also assert that this cursor here appears. This tracks the mouse, so you know the current time on the chart. That would be another like really great thing to test. So here's what a test like that could pretty easily look like. You could have a test that chart tooltips are being displayed. So you're going to get the element using sci.get or this helper thing that I like. We have a custom command find chart surfaces. All of our charts are SVG, and there's like some layering stuff going on with recharts. So this command basically returns like all of the lines. You can just think of it in that way. And then we're taking the first one, and then we're going to trigger these mouse events on it. So that will make the tooltip appear. And then we're going to get the element for the tooltip, make sure it's visible, and take a screenshot. So this test has tested that when a user hovers over a chart, the user sees the tooltip, like it's visible, and we also have a screenshot of that tooltip that we're going to use as a Happo test. So to make that work, we need the fixtures. But as part of that, we actually get like a unit test from the Happo screenshot. These numbers over here, they shouldn't change because you're using fixtures. All of this stuff shouldn't change. So you're testing the formatting, of course, you're testing that the thing is here, but you're also testing the accuracy of the data, or at least the accuracy of the data as it's like presented through the UI from the fixture. So there's a lot going on here, and it can actually be really short. You can imagine this is sci.get up here. So we only have like one custom command. This could be like sci.find g. So we're not doing anything crazy here. Happo Screenshot is provided by the Happo plugin, so this is actually pretty easy. drag. Drag is not as easy. So drag is just another mouse event, and it's specifically like a mouse down as you click, a mouse move as you're dragging, and then a mouse up to complete the drag. So this part of the Cypress test is like really easy. It's basically the same as what we saw before. It's all this other stuff up here. So here, this is an actual test for that like blue histogram I showed earlier with like the distribution of spans and stuff. We're getting that element, and specifically when we do this L0, where we're getting the actual DOM element, not like the Cypress wrapper around it. And we're getting the bounding client rect, the geometry of it, and then we're calculating where we want to perform our click and drag. So we start the drag like 25% over. So if you imagine like we've got like a number line here, like 0. So we're starting at 25, click and drag over to 75, let up. That's what we're doing here with this. And then that drag is happening in the middle of the container. So once you get past the math, this is actually really easy. And this is basically the same thing as what we were doing before. And here in this test, the thing that we care about is that when you click and drag on this histogram, that we set these like min latency, max latency bounds to like highlight the specific area that you've highlighted. So that's drag. Yeah, I think there'll probably be some questions about it in the chat. I look forward to that because it's like it can be really easy, and then you get to the math. There's some other cool Cypress interactions. So there's side.viewport. You can use that to set the size of the browser window. You can actually call it a bunch. So you can use it to ensure that your page is responsive and that it expands and shrinks as the user changes the size of the browser. This couples extremely well with Happo Screenshots. So you can do a screenshot test of like the expand and contract, and if it works, they'll probably look the same. But if it doesn't work, you'll see that like elements might be like overflowing their containers or not shrinking or whatever. Side.scroll to is another one. It would be like really great to test virtual scrolling, like infinite scroll. With this, you can like scroll down to an arbitrary amount, and then you could use like regular Cypress assertions about like elements being visible and attributes and stuff, or you could use Happo to assert that too. It's like a level of interaction and control that I don't think is really available outside of like this style of testing, outside of like Cypress. Scroll into view, it's a function, it's there. You often have to call it if you're like trying to interact with something that might be below the fold of the page. Call it, definitely. It has scroll in the name, so that's why it went up top. There's some staples here. Sci.type, it's what you expect. You can use like other things like this. Sends like a right arrow keyboard event. It types a right arrow. You can also send sci.type on any element, so you don't have to be in an input field. You could like check that like your chart zoom pan situation works well with arrow keys. There's a bunch of click events, some check and uncheck things, select. Yeah, so lots of great interactions with Cypress. So that's it. Thank you for all of your time. I really appreciate it. I owe many thanks to JavaScript and Friends organizers for setting this up and inviting me to talk, and also to the great front-end engineers I work with at Lightstep. It's been really exciting to be working with them on so many things. And of course, to the other people who've taught me about testing, like throughout my career, I worked with some really great people over the years, and I'm thankful for everything I've learned from them and hope to pass on as much as I can. Thanks.